Much for the invitation. It's a pleasure to be here. Some hiccup with the plane yesterday, but anyway. So I'm representing the European Building Automation Controls Association. And what I would like to do is I would like to give you some, I would say, hands-on explanation, dirty hands explanation what this really means, because many people have already alluded to building automation and controls, and when we spoke I think you said, or we said it's very evasive. Nobody knows exactly what it means and what is the link to smart buildings. So I hope I would clarify some of the issues here, what they do, and in particular also what is the role of this building automation and controls, I would say product and functionality range on the way to decarbonize buildings, smart buildings. And in doing so, I will focus more on, I would say, the stuff that you have within the building, within this meeting room, for example, the energy flows that you have here, providing some cooling and heating, maybe sometimes in winter. Is it still winter in Malta? I don't know. Okay. Maybe just as a scene setter, the legislator in his wisdom, already 2010, I would say, has put a lot of emphasis in the current Buildings Directive on technical building systems. So we have an article which basically already says that for energy performance optimization, you need to adjust and control the technical building system. So basically here, what was meant is to say, well, when you have a technical building system, such as a heating system, hot water system, and air conditioning system, it's not enough to have an eco-design measure for the boiler or an energy label for the heat pump. What is, in my personal perspective, at least equally important, is the system optimization aspect. And that is something we have since 2010. Another example is in the Energy Efficiency Directive, where we have the provisions on metering, billing, consumption, providing energy consumption info on the heating bill to to tenants and occupants there. Basically what is said is it makes no sense to, I would say, provide information to citizens how much they can consume if they are not enabled, empowered, so to say, to draw the right conclusions and in that case have a sort of a temperature control that enables them to basically, well, take control of the energy consumption that they spend for heating. So what is this building automation and control actually, and what is it doing? What we basically say is this equipment and functionalities that manage the energy flows and usage in the buildings. So all the, I would say, the pipes and the valves and the ICT that you have here that manages, I would say, the indoor comfort, the temperature in that room, for example. So they control, integrate, optimize the performance of the technical building systems, space heating and cooling, hot water. They come in a very large variety. They are products and components, very hands-on, brass, valves, to, I would say, communication protocols, electronic ICT-based stuff, cloud data storage, and so on. And as I said, their performance is decisive for making our, I would say, indoor environment comfortable and reduce and optimize the energy consumption over time. I think a very important aspect that you do not do it once and then you forget about it. You close the ceiling, you screw up the panels, and then you forget about it in the next 10 or 15 years. And the performance that you have calculated by sophisticated standards deteriorates over time, and in 5 years from now, basically your performance is a completely different one and a much worse one usually. And they come in various degrees of complexity. So a hands-on example is two basic functionalities that, in our view, everybody should have. It is room temperature control and, in larger buildings, hydronic balancing. And what it means is, it is this very simple thing. You have a thermostat on your radiator that basically opens and shuts the flow into the radiator according to the ambient temperature. Mechanical, nothing very smart in that sense, not related to demand-side response for electricity. A very simple thing, but which has a huge impact on your heating energy consumption. That comes in more and more sophisticated interactive stuff. You can control them from your mobile phones. Many companies do these products. And then hydronic balancing means, it's a little bit nerdy, it's physics. It means that basically you arrange your fluids that circulate in your heating system in a way so that they're evenly distributed. If you don't do that, basically what happens that if you have a large multifamily building, the upper parts tend to be cold, you do not have enough heat, people complain, and in other parts of the building it's hot. And it is very basic stuff, very basic functionalities, but which are not implemented basically in a large part of the residential building stock. Doesn't cost much. We estimate it's basically 10 euro per square meter investment, paying back in about 2 years. More sophisticated, if you go here. Oh. Could you help me to go back?
There's a red button.
Yeah. That is the more sophisticated stuff. That was a building management system that was mentioned several times. It basically has a pyramid structure. It has some valves in the rooms here, for example. Here you have something like this sitting up there. No, it's a combination of brass and something that communicates with the central controller that you have on top of the pyramid there, and all together basically makes that the energy is consumed, is delivered in the right quantities, hopefully, to the heat exchangers that you have here. And that is basically a building management system that then optimizes thousands of data points, depending on the complexity of the buildings, and that you can basically then optimize in real time if you have the right technologies implemented. So what is their task? I would say in smart buildings, looking ahead to 2030, 2050, and the decarbonized buildings that are part of the Commission's proposal. We believe that the decarbonized buildings need smart and well-performing automation controls to optimize the performance of technical building systems, because they become increasingly complex. It was mentioned, renewables, demand-side response, new technologies, and you have to manage the interaction. Heating should not act against cooling, for example. What becomes increasingly important is, I would say, that you control, I would say, the dynamics in the system, because with better envelopes, internal gains, that we sit here and everybody of us radiates, I think, 80 to 100 watts. That becomes more and more important. The better, I would say, the envelope is insulated. So related to that is the need to basically do the optimization in real time. So it does not help, as I said, to do it once and then forget about it. But it is basically a crucial element to continuously in real time monitor, control, and adjust the energy use, so that you are sure that you can maintain the performance once it was commissioned, the building, over time. So that is often referred to as continuous commissioning. Well, extremely important for investors and for, I would say, matching actual use with expectations. So eu.bac has I would say, a program that tries to support these functionalities and these principles. It's a certification system for both, I would say, parts of the system, like, for example, electronic thermostats, and it has a part which looks really into the system optimization aspect over the life cycle. And I would say the whole idea is basically to ensure well-performing building automation and control systems, and create basically added value for investors, managers, consultants, owners. The details of that are on our website if you're interested. I can also give more elements if you like. But I would say, despite the Article 8 that we have since 2010, and that you didn't change in the first paragraph of that, and despite, I would say, some efforts that we try to put on the ground, we see that there are huge, I would say, improvement potentials which are relatively capital light and which pay back typically in 1 to 3 years. Some studies say it's 14 MTOE in residential and 40 MTOE in non-residential by 2030. And the problems are, as I said, in many millions of dwellings, hundreds of millions of dwellings maybe, there are lack of basic functionalities, no room temperature control, no balancing in the heating system, no dynamic system integration in the non-residential sector. And the reasons are often linked, I would say, to split incentives. Somebody who is, you know, at the very last moment in time, trying to squeeze out a few bugs of the configuration of the system here, rather hands-on. I would say missing information. I would say know-how and yeah, practicalities that are related to I would say, the construction of a building on the ground, so to say, very practical. So our conclusion is that we believe that the new legislation should basically support that the technical building systems, heat generator, for example, plus all the system around it, performs optimally 24/7 for the lifetime of the building, and to that extent, the upgrade of the existing provisions, the EPBD, is needed because this aspect is key in our view for 2030-50 policy and decarbonize buildings, reduce energy bills, maintain building performance over time, and really ensure comfortable and healthy buildings with least energy. And so we believe that an upgrade of the EPBD article on technical buildings is needed. Now, we believe that also what the mechanism that you have put there with the inspections versus Article 8 probably may not be enough to address the key, I would say, split incentives issue. If you put, I would say, who puts the money on the table, the capex at the time when the building is commissioned and handed over, probably is not tackled with the OPEX, basically, benefits that you would gain with a more consistent and more, I would say, less timid rollout of support for this system optimization aspect. Thank you.